let's do it. Okay, so I'm going to show you one more thing. I'm not going to go really in detail on this, but I just want to show you the concept. It's actually not as hard as you might think it is. What happens when we bring this and we take the derivative of this? What is the derivative of, how would you say to do this? Derivative of y. What's the derivative with respect to x of y? What's the derivative of y with respect to x? Yes?
5 times the derivative of that, 6.
5 of this to the fourth. 3x to the second minus x, like that. Now what do we have to do with this? Find the derivative of that and multiply it. So what is that? 6x minus 1. Good. That's the right side of the equation. But what is the derivative with respect to x of y? How do you say derivative? What is derivative of y with respect to x? How do you write that? dy dx. Yeah, that's dy dx. So we want this to go here. It's dy dx. So really the derivative of y is dy dx. It causes that mess to be there. Okay. So that's a good start. Okay. Gave you these notes, right? So now what we want to look at is, what is implicit differentiation? Well, implicit differentiation is basically when there's a y stuck in your equation, you can have different situations of how to take the derivative. I'm going to skip over this for a second and go to this. You see the way that this is? Like, you see how to take the derivative of this? Like, how would you take the derivative? What would dy over dx be here? What is this, 1 over x? How do you make that, how do you take the derivative of 1 over x? Don't say ln of x. Because that would be backwards, right? You could use the quotient rule. I wouldn't recommend it because 1 over x equals x to the negative 1. So now bring down the negative 1 and make it to the negative 2. Yeah, so I would make it negative 1x to the negative 2, which is really negative 1 over x squared. See that? And that's dy dx. That's dy dx. Now, would you say that this equation and this equation, what's the difference between, are these equations similar on the left and on the right?
Yeah.
Yeah, they're very similar, aren't they? What's the difference between those? The difference between those equations is this is like water and this is like ice. You know what I'm saying? Like this is like steam and this is like ice. They're just different forms of the same equation. It's the same equation. So now I'm going to do this equation by something called implicit differentiation. So let me explain.
I'm sure we just divide by that.
You can, but I'm going to give you problems that you can't with it. This is an example where you can. We start with something easy, but then we go to stuff where you can't. So in this case, we have a product. So what's the derivative of x? Derivative of the first?
1.
Yeah, 1. What's the derivative of y? We said it earlier, right? dy dx. The derivative of y is dy dx. So we're going to have this. Let me do the color coding again. Sorry. Okay, so derivative of the first times, oh sorry, I didn't do this right. Wow, a little rusty. Derivative of the first is 1 times the second is simply y. Plus derivative of the second, what did we say it was? We said it right, dy dx. I don't know if it's great to have a product rule here, but oh well. Times the first, and what was the first? X. Okay. So let's find dy dx. How would you find, well actually, what is this equal to? So isn't there an equal sign here? Equals, what's the derivative of 1? 0. Okay. So aside from the product rule, what I'm trying to press into you is that dy dx is the derivative of y. When you hit a y, you can't just get rid of it like when you hit an x. You have to put dy dx. So now I'm going to solve for dy dx. I'm going to say dy dx times x is equal to negative y. I just subtracted y from both sides, right? What will I do now? Divide by x? Yes? To me, this is like magic right now. To you, this is maybe just more confusing. Hopefully not. I'm going to divide by x. So I have negative y over x. So what I'm saying is that on the right side of the equation, I got this. And on the left side, I got this. But what is y equal to? Yes. What is y equal to? Yes.
1 over x.
So what if you put 1 over x there instead of y? What would happen to that black circle? Yes? It would become the red circle. So we got the same answer by a much more complicated way, yes? By a much more complicated way. But sometimes we have to use this much more complicated way. My apologies that the product rule was in the first example ever. That wasn't probably the smartest, but let's do a couple where they're not there. Okay? What do I have, like a minute? Less? Not even? Before my warning?
5 minutes.
But you're going to give me the warning, I think, before, right?
Warning.
Yeah.
Dang
Oh,
it.
yeah, minutes more. Yeah.
There's like 40 seconds left.
Like the bell really rings like 2 minutes before it's supposed to. So.
But like to work on it.
We're not going to listen when they start with announcements. We're not paying attention to that. Okay, so here are the steps to solve, and I'm going to do this example right here, okay? So I want to do this example right here. Hopefully I can make it bigger. There we go, perfect. So let me show you what you're doing. If it's easy, solve for y and proceed as usual. Would you say this is easy and you can solve for y?
Yeah. No.
I would say no. I would say no. If it's not easy to solve for y, use implicit differentiation, which is really just a chain rule. So I want to take the derivative of this. So what do you think the derivative of y cubed is?
3y squared.
3y squared, great. Now here's the trick. You have to take the derivative of whatever's inside here, right? Normally. Which normally is an x, yes? And the derivative of the x is normally 1. But what is the derivative of y? dy dx. So you have to actually multiply by dy dx here, here, and here, but not here. Because the derivative of y is dy dx, the chain rule says bring down, leave this alone, go to the second, and then multiply by the derivative of the inside. Well, the derivative of the inside is y, and the derivative of y is not 1 in this case. It's dy dx. Because it doesn't match. The variables don't match. We're taking the derivative for x, and we hit a y, unfortunately. So now we have to chain rule this, which will give you a dy dx. If that's the case, what do you think the second term would be? Exactly, 2y dy dx. So this term would be plus 2y. That's fine, right? Plus 2y is fine. But when you hit the y, it doesn't really match. You're taking the derivative with respect to x. And when it hits these numbers right here, when it hits those, it doesn't really work out that well, and it needs to be dy dx. We'll go into more detail later, but how about the third term?
Minus 5.
Yep. Minus 5
dy dx.
dy dx. Now the good news. Minus x squared, how do you do the derivative of that?
Minus 2x.
Minus 2x, leave it alone, as normal, equals what?
No, 0.
0. Because negative 4 is 0, right? Negative 4 is 0. So now here we got this guy. That's just minus 2x equals this guy, derivative 0. Not as bad as it looks. It looks a lot worse than it is. It looks horrendous. It looks very ugly. But it's very useful because it's pretty rare that you get one variable type of things going on very often. More likely you're going to have 2 or 3. So that's why we have to have this. Then you really just solve for dy dx. Do you know how you would do that in this case? Like, how would you solve for dy dx? How would you get it alone? What I would do is I would take the plus, I would add the 2x to both sides, right?
Good afternoon, MHS. Here are your
now
afternoon
2x
announcements.
equals.
There are still some pictures from the homecoming
And I
gift
would
that have
take
not
the
been picked
dy
up.
dx
If you had a
out.
picture taken and did not get the printout, see Miss Flaherty.
And what would be inside?
Are you a high school student that is interested
I
in
distributed,
educating
factored it out,
sixth
pulled it
graders
out.
on the dangers and harmful effects of drugs, alcohol, and
3y
tobacco?
squared.
If so, please think
That
about
makes sense?
completing an application to join Peer Ed. Applications can be found outside Miss Morin's room B113.
And how can you
Completed
get dy
applications
dx
may be
alone?
submitted to either Miss Morin
Divide by that
or
whole
Mrs.
mess.
Henry to be reviewed. Senior
Divide by that
applications
whole
are
mess.
due by next Friday, and underclassmen applications are due by October 27th. The Environmental Council Group will be having its membership open house today. All students in grades 8 through 12 are welcome to join. Stop by and see what we are all about. And the Halloween bonfire is October 21st, 6 to 9 p.m. $5 to get in, $3 if you wear school spirit. Proceeds for grades 7 through 12.